Pretty exciting today. You know, one of the opportunities we've had in DX over the years is these great conversations with developers, you know, from all walks of life, all companies, in industries, talking about how we work together. And, you know, one of the best things of the job is that opportunity to work with developers on frontline problems and new technology areas.
So why don't we get started with machine learning? And my understanding is you were up at Snowbird doing some skiing. Let's take a look.
What's going on?
How about that tram ride?
Pretty good, huh?
That's a sweet tram. Where am I, man? I just woke up. I got on a plane last night, landed somewhere. Where am I?
Well, you're not going to get a better tram ride other than here at Snowbird. And thanks for joining us here at National Academy. We're excited here at PSIA ASI. I mean, we are the educational arm of the snow sports industry, and we want to anything that drives education forward that can help us deliver a better product out on the snow, we want to be a part of. We have our top pros, our top athletes. We have a national team made up of 13 alpine skiers. And what we've been doing is we've been putting these sensors on them, as well as we've been putting our sensors on our members, our ski instructors who are out here skiing with them. And what we're really trying to do is we're going to find out, evaluate their movement patterns, what makes these national team members the best, and then overlay that information and take a look at how can this give the general public a visual to become better at the sport they're doing.
Yeah, this is pretty cool from the tech side. So normally when we think about sort of capturing sort of IoT or, you know, the puck here device data, people think about sort of low frequency. Hey, did somebody turn a switch on or off, and not very often.
Yeah.
The notion of sort of having an IoT device at high frequency is sort of an interesting problem because you got to capture people as they're coming down the mountain. And so the team's done a good job of building a sensor that operates at high frequency, low costs that we can attach to the skier or the skis, and then connecting it through Bluetooth to the phone, which is pretty cool because that gives you the high frequency part. Then feeding that all up to the cloud in Azure so that we can collect all the data. We have sort of a very high amount of data that then we can go run machine learning models against. Over time, you think about applying proactive or predictive to this, a little bit of AI, and really sort of in the ear of somebody coming down saying, hey, that last turn, you know, you leaned in a little bit too far, or you did something a little wrong. You know, the next one changed a little bit based on your style and your skiing and what the pros do. So really cool to sort of take the best of sort of IoT, Bluetooth, sort of connection up to the cloud, sort of the Azure side, the machine learning side, big data side. So for us, fun technology pulls all the pieces together. For you and the rest, sort of how do we think about the athletes and to your point, training and education, pretty slick partnership combination.
We're excited. I mean, all the members and our teams that have been out there, when the Microsoft team has been like, hey, here's the phone, here's the app, and they're like, wait a minute, this is real time, they can see this immediately. It's kind of blowing people's minds, the possibilities that are out there. So we're looking forward to seeing bringing this thing to life and seeing what it can do for us.
So why is this important to you guys?
Being the arm of education for the snow sports industry, we really want to be at the forefront of any innovation. Our charge is to grow the snow sports industry, to get people to be safe and have a good time out there. And if this is something that can help them be better, we want to be a part of it.
All right. Well, look, I'm all about getting better. Let's go out and test this out. I'm interested to see if I get better.
Looking forward to it. Let's do it.
All right, let's go.
Yeah. You ready to get suited up and go skiing?
All right, let's go skiing. What do we got here?
Well, we have the sensors. So what I'm going to be doing is I'm going to put them on your upper body here.
Okay.
They're going to be evaluating your upper body movements, and we'll also put these on your knees.
Yeah.
And from there, they will be able to track all your body movements. Every time we do a run, what you're going to do is you're going to push that red button there.
Got it.
Started sensor tracking experiment 13.
Experiment 13.
You ready to go skiing?
That's me. Time to go learn something.
Let's go skiing.
Let's go skiing.
Yeah. Pure fall line, straight down to where all those people are.
Straight down?
Straight down.
Okay.
And you'll just follow me.
Okay.
Ready to go?
Yeah, hold on.
Started sensor
Let's go.
Let's do it.
experiment 20.
Yeah, nice. It's perfect. Yeah, so we'll take one more run and get a couple more shots. And let's take a look at the data.
Okay.
You can see all the sensors on your body.
Right.
You can see where they're hooked up, 2 under your knee, 2 on your elbows or below your elbows. And you can see how many test cases we've done.
Right.
So.
And it's telling me the amount of vertical. I think it told me max speed. I wasn't
The app tells all that. Max speed, vertical, all of that. I thought it was cool because when you passed, I heard it said you hit 900.
Yeah, 900%. Yeah, that's pretty funny.
All right, push that sensor again.
Okay, which way are we going?
And we're gonna do a little bit shorter radius turn, and you follow me this one, and then we're gonna do one more. Here we go.
Okay, cool.
Yeah, nice. Well, let's head on down to the base area, and we'll check out the data. That was a good day, huh?
Good day.
Yeah.
And now we have all the data on sort of how I was skiing, so we can flip it back to the software guys and see what the data tells us.
Yeah, no, I'm looking forward to seeing that, and that's where it's going to help us education-wise the best.
Oh, look, personally, I think I was as good as Nick, but I'm really curious to see what the data says.
Well, let's take a look. What we wanted to do is spend some time looking at how we can use machine learning to understand if people are doing a good job skiing or not.
Yes, John. We actually created an open source sensor kit to enable anybody, all app developers, to connect to sensors to gather that data and then upload it to the cloud and use the machine learning models.
Okay, so it's going from the skis to an Azure SQL database.
We also partnered, John, with the Professional Ski and Snowboard Instructors of America to actually analyze this data and make a really smart machine learning model that really enables skiers to understand the movement.
Okay, so let's go into Azure Machine Learning Studio. We'll start with a blank experiment, and I need to import some data. I'm gonna just drag that over here, and you said it was in an Azure SQL database.
SQL database.
And put that database server name
Yep,
in.
and for the database name, you can use our sensor study. And then we're going to select some of the data.
We got to get that query in.
It's actually very, very helpful that the Machine Learning Studio provides a way to provide that initial query.
This is how we get the data out of that database. So yeah, there we go, save. At this point in time, we got the data. Now, I know you and Patty spent a little bit of time on this, doing some processing with some of the key kind of R libraries, these packages.
Exactly, yeah.
So what we need to do is we need to import one of those packages, and then we're going to run a script that Patty came up with to do the data. Now, this is a set of R scripts. So execute execute R script.
R script, yep.
And all we need to do now is we need to pump that into here, right? And import the data in, and now we've got an R script. This is the default.
That's what the Machine Learning Studio gives you.
Yeah,
by default.
so we're gonna just kind of nuke that.
Use Patty's.
And let's use Patty's. This is the other thing she said we have to do. So I'm just gonna go grab this. Tell me about what's going on here.
Yeah, we're taking data directly from the sensors and mapping them to composite features within our data model. So for example, I'm really looking as a ski instructor, I'm really looking at the upper body rotation, for example, or I'm looking at the feet position.
So this is the difference between the hands. You're grabbing the 48th row in the 100
column.
Yeah, so that's all this raw data. You're doing the difference, and that gives you the difference in X, Y, and Z, and then you're storing it into that data set.
So the amazing thing about this data is that, John, we were able to identify 2,070 features specific to skiing just by analyzing the data. And those features is exactly what you're mapping to.
Yeah. Now what we'd like to do is we'd like to train a model on this. And we'd like to see if that model could be used to predict whether or not Googs is going to be a good skier.
Exactly. That's exactly what we're trying to look at.
We got this data coming in. We're going to want to train it, but we're going to want to train it on only a part of the data, and then we're going to want to look at the other piece in order to check our predictions. And that's pretty straightforward to do. We're just going to split it 70-30. And let's execute the results of that R script down to the split data. And now let's go to that model, train the model.
Yeah.
So train and machine learning model that we're going to train. And we're going to train that model with that 70% of the data. This is a pretty simple data set. And so we'll do the really simple one because we kind of know binary. We'll do the two-class logistic regression model. We'll pull that over here. And that's an input. That algorithm then becomes an input into the training model. In order to do an evaluation, we're going to need kind of two scores. We're going to need the score that we got from the training data, and we're going to need the score that we get from the data that wasn't used in the training set, because that'll give us an idea of whether or not we actually know what we're doing here. So what I'm going to do is I'm going to pull out those two score systems. So we'll have one here, and we'll have one here, and we'll connect this one to the this data right there.
Yep.
And we'll have as input the model, right? And then we got to do one more, which is now we need to use this one. This one over here.
Yeah.
And then let's take that non-trained data. All right, now we need to do the last little step here, which is evaluate that model, right?
Yep.
And that takes the two inputs. And I think we're actually ready to go do some machine learning and try it out. Anything else we think we ought to do?
Yeah, just one last thing. So remember, John, when we created the features, one of the features that we created was actually called the skill level.
Yes.
So what we want to do is we want to go into our training model. Right, so exactly, and select that skill level. If you type in skill level, this is one of the composite features that we identified to
distinguish between Googs and the Pro.
Exactly.
Let's take a look at the results.
Oh, that's an incredible score. So we actually have an incredible accuracy here, John. Close to 99% accuracy.
I think what it's saying is it's pretty easy to tell the difference between Googs and a professional skier. Is that what we're really saying here? Okay. Now, what I wanted to do is I want to spend a minute or two talking with our data expert, Patty.
Absolutely. Thank you, John. Thank you. Thanks.
Hey, John.
Hey, Patty.
So you're looking at the model.
Yeah, this is pretty incredible.
Oh, the results are great. There's great variation between these body positions and patterns of an intermediate versus a pro. So what you can see here with Googs is that it's markedly higher. So he kept his body upright versus the pro who was crouching, leaned into the hill, and a real significant difference between those two here. I also use Jupyter Notebooks. And this is a cool tool because it really keeps your analysis and your story and your narrative clean and allows you to kind of collaborate around your findings with others and really push it to the next level. One of the things that I like to look at when I'm kind of understanding a model, here we're understanding the variance.
This tells us what the most important variables are between the pro and the intermediate.
That's right. So
wow,
that gives
that's fascinating.
This shows you at a high level the variation in the model and how many components of variation it takes to explain your model. And what this tells you with this nice sweet curve is that, yes, with a small subset of variables, you can really tell a very clear story. And then this next piece is mapping the components of variance with each of the variables. So each of the variables here is labeled on one of these arrow vectors in blue.
Okay.
And so we can understand the story of that variance. So what you see here is this really nice differentiation. So what you see over here on the right side is the pro, and then the kind of that.
Wow. It's really that stark.
But this is beautiful. You can read these and develop kind of an intuitive notion of what the variations are.
It seems like machine learning and artificial intelligence is going to be very rich and as a tool to help people improve their performance and do other things.
Oh yeah, it's really exciting. I think this is just the beginning.
We really appreciate you guys coming. As John and I always talk about, we love the conversations we get to have with the folks we get to work with. Why don't we start off with just a little introduction from everybody?
I'm Kevin Grant, Chief Technology Officer for Farmers Edge. Farmers Edge works in what we call the decision agriculture space. We manage grower data, trying to optimize decisions on the farm to maximize profit, minimize cost.
Hi, I'm Sal Sayed. I'm the CEO and co-founder of Arcos Golf. And what Arcos is a hardware and software platform for golfers. It tracks all their data, and then using all that data helps them make better decisions in terms of club selection or understanding their strengths and weaknesses.
Tell us a little bit about how you got started working with Microsoft. What was the kind of business problem you were thinking about where AI might apply?
When you look at the history of golf, 100 years ago, every single round was played with a caddy. Today, less than 3% of rounds are played with caddies. And the idea, what the caddy was doing was helping you make optimal decisions in terms of your club selection. Every time you step up to the ball, what club should you hit? Today, golfers are kind of doing that on their own. And we thought the perfect application of all the data that we're collecting is using machine learning to make that decision that much smarter, that much more intelligent.
Actually, not unlike the story we just heard. When you're in farming, you rely a lot on your data and a lot on expertise. So your farmer has trusted advisors, like their fertilizer reps and their seed reps and people of that nature. In the past, you've had kind of these mom and pop agronomy shops that could service 20,000 acres or 30,000 acres. And what we want to do is we want to take that model and be able to service, 250,000 acres per rep. We really feel, and this is going to sound a little cliche, but we feel like this is a market that's really ripe for disruption. So there's a lot of
pun in there.
Yeah.
It is ripe and farming, but we'll just keep going. Cliche and pun all in one. You're on a roll. Go.
We're collecting, real-time equipment data, whereas before you might have collected a yield map at the end of the season and maybe an as-applied map at the start of the season. Take all of that data, push it through a machine learning algorithm, and see what comes of it.
And what kind of impact are we talking about? Is it cost? Is it increase yields?
We want to get as much yield as possible for a given amount of fertilizer. And in order to do that, we need to know where to put that fertilizer.
Are you thinking ahead to doing some deep learning on this, or where do you see this going?
We're sitting on hundreds of terabytes of data, quickly moving into petabytes. I think we're going to need to look to the complexity of deep learning, TensorFlow, those sorts of things to really take us to the next step of innovation.
One of the things we love doing are these hack fests, where we get your engineers in a room with our engineers. Tell us a little bit about how that went.
What was eye-opening to me was how quickly, if you have the data, that you can get all these insights. You can actually predict outcomes at a very interestingly high rate. So for example, right now, with 70% certainty, I can tell you before you've taken a swing whether you're gonna get a par on that hole or not.
Wow.
And
That's not good in my case, 'cause I don't get enough pars, so this is just all going wrong.
it helped us realize the power of machine learning because we hadn't gotten our hands dirty till then. Then it became our mission. We're like, okay, wow, this is so powerful. We have all this data. We're going to build the world's smartest caddy.
Now, I'm sure it didn't all go perfectly well. What were some of the challenges you had to overcome?
I'd say one of the things that if there was an option to undo a model, it would save us a lot of time. And then maybe version control.
Yes.
How do you guys think about sort of either low bit rate or sort of, connectivity in general for the farmers and helping them figure that out? Because that's one of the hard problems when you think about large spaces and, low power sensors.
So that actually turns out to be one of our biggest challenges, especially in the other world areas where you have very limited cellular coverage and things like that. We might be out there collecting data for hours and hours and hours, and we have to store that data locally. But
Yes.
then when we get back, we don't want to run the battery down on the tractor while we're trying to get it pushed up. And so, there's some things that are pretty tough to solve out there.
That notion of sort of compute on the edge and compute in the cloud is one that we're pretty focused on right now as a pattern we see growing over time, and you're literally on the edge of that conversation.
That is exactly
so are
right.
you in many ways, with the fringe.
And one of the great things about the role is talking to you, talking to many other companies, we hear feedback on how we should improve. And it's great to be able to collect that together and then bring it back to the engineering teams. And in a lot of cases, maybe even build some of the pieces so that we can help the companies, make more rapid progress.
The sort of machine learning and AI, it will have an impact on sort of all horizontal sort of business processes or sports processes. It'll hit every industry out there. It's going to be a more exciting time in this space. I'd love to get your thoughts on what you see. Just if you go out a year, 2 years, 3 years, the things that you get excited about in this space.
One thing we're seeing is a renegotiation of the interaction between the human and the computer. So if we look even 20 years ago or 25 years ago, all of the insight and all of the decision came from the person, and the computer was just kind of a dumb servant to help them along. And what we're seeing now is almost a reversal. A machine might not be able to say why something's happening, but they can say that something's happening. And at that point, we need to send the agronomist out to help.
I'd like to build on that. First thing we're doing is making golfers smarter by helping them make smarter decisions. But the reality is this data that we're capturing, we're tracking everywhere the golfer's going, when they're playing, what clubs they're using, how are they playing. This is going to make the entire industry more efficient. And I would say that exact theme is going to play out in literally every single industry where the decisions are going to be that much smarter. And as a result, the economies are going to be that much more efficient.
That notion of AI complementing, human capability and business outcomes, it's just a ton of fun, and it's an area where I couldn't be more excited. And we appreciate you guys making the time to join us today. Both of these spaces, we both love to eat. John's a key foodie here, and I actually like to play a lot of golf, so this is win-win. And let's keep going together. We appreciate it.
Keep up the good work.
Thanks.
Thank you.
So we're trying to do fusion. This is what happens in the sun. It takes temperatures like 100 million degrees. And people have been doing this for a long time. There's been a lot of R&D in national labs and other areas. And you look at programs that use big magnetic fields, large superconducting magnets to hold, like create a magnetic bottle, or other programs that use massive lasers and they crush things to extremely high density. And so what General Fusion's trying to do is we're going to form a magnetized plasma, so it's super hot gas wrapped in magnetic field, and compress it quickly.
Now, what's this?
So we measure things like magnetic field and temperature, but you can't take your mercury thermometer and stick it in there and say, oh yeah, okay, it's 1,000,000 degrees. You've got to find other ways of doing that. We need to figure out ways not only to process it for our own use, but as we grow, we want to engage more and more of the scientific community. And so systems to be able to do that is key to us. Brendan here has been working with Microsoft on how do we handle all of that data.
So yeah, here we've got our oscilloscopes capturing the data and digitizing the data that we then are going to have to process and give this data to physicists internally. How you process that data, how you store that data, also how we distribute that data and share it with physicists outside of our organization. These are all of the problems that we're solving with Microsoft.
Hey, why don't you take John over to Pi 2, show him what he's up to.
Sounds great. So this is a power plant scale plasma injector. So this is a scaled up version of the one that you saw before.
Wow. So this thing is big.
Yeah.
Now, what kind of data are you gathering in a plasma injector?
Well, each valve will produce a trace that shows us exactly the timing of each valve, so we can synchronize those within microseconds. Here you can see all of these fiber optics. Each one of those is a signal, and this is just on this end of it, and we'll have much more instrumentation down on that end. Wow. So as we push the plasma down the plasma injector and inject it into this target chamber, probes collecting magnetic field, temperature, or density. Okay. Each shot can produce 100 megabytes to a gigabyte of data, and we take a shot every 5 or 10 minutes on as many as 4 injector stations. So we can produce over 100 gigabytes of experimental data in a day.
Okay, very nice.
Let's keep moving, John.
Okay.
So this is our prototype compression system. This is the other half of a power plant. So we pump liquid lead lithium into the sphere. We pump it in tangentially and get it spinning. The plasma is injected inside that cavity, that cylindrical cavity, and then these pistons behind me will all hammer the surface of the sphere, and that will send an acoustic pressure wave through the liquid lead, compressing the plasma.
And that's what ignites the fusion.
Yeah.
Now, normally somebody using this amount of data would use something like Hadoop.
What we realized very quickly is that in that case, you're married to a Java-based environment, and we work with a whole variety of different codes. Some of these codes have decades of collaboration between scientists, so we want to be able to use the right tool for the right job as opposed to being married to a specific product or a specific tool chain.
Makes sense. So one of the things that we've done together, which I think is super fun, is instead of using Hadoop, we use this new tool chain around Pachyderm.
Absolutely, yeah. So Pachyderm is a new tool chain, a new tool that provides everything that Hadoop does, but it lets us define the actual processing code using containers. And Pachyderm then schedules those container jobs using Kubernetes. Kubernetes is a container orchestrator that will then distribute those jobs and load balance and scale as necessary.
Wow, we're looking here at what might be the future of energy on the planet, and we're building out a new tool chain so that researchers and people developing it can look at it.
What's really exciting too is that the use of these open source scalable tools, it lets us focus our resources not on software development, but on fusion and science.
That's great. Now the liquid lead comes out of here?
Yeah, so we actually we melt the lead here.
We're back again. We're going to move from machine learning and talk a little bit about modern app patterns. We have our friends from General Fusion up north, second Canadian company today, pretty awesome. CoreOS from San Francisco, representing a little bit of the South. Can you guys just introduce yourselves, talk a little bit about, let's start with General Fusion, a little bit about your background and what you guys are working on, and then we'll pop over.
My name is Jonathan Fraser. We're from a company called General Fusion, and we're working on changing up the way we're doing the data analysis for our prototype power plant.
And I'm Brendan Cassidy, also with General Fusion. John and I are both working on a data science initiative to manage our experimental physics data using modern cloud-based techniques.
And I'm Rob Sumsky. I'm a product manager and designer at CoreOS. And we're bringing containers to the enterprise, cloud-native applications, helping folks like yourselves build their data pipelines and run their web applications.
This one's exciting, like a fusion conversation in software. Tell me a little bit about how software plays into this whole conversation.
So we're working on a way to take our data analysis platform out of a more traditional stream that you would encounter working in these sorts of laboratory environments. And we're trying to take that and marry that with some of the innovations that have been done in the modern web applications so that we can scale this analysis over all the data that we're collecting on our Fusion machines.
Tell me a little bit about the connection between Microsoft and General Fusion. Like, how did we connect on this conversation?
We were put in touch with the DX group at Microsoft. They wanted to send some people up, and we sat down and hacked together and got, I believe it was the first deployment of Pachyderm on Kubernetes on Azure up and running with a couple late days and a lot of hard work and a lot of fun.
I think the thing that was really interesting about the design that we came up with was this notion of using containers as a way to package up the parts of the tool chain and then be able to use Pachyderm on top of Kubernetes to go distribute that. That's a little different workflow than you typically see with large amounts of data.
The middle ground there was to pick a container that we can put these tools into and just inject the data into it so that the system is agnostic whether it's running Fortran or some older physics package.
Or writing new stuff in new languages. It's the right tool for the right job.
One of the things that we've been really enjoying is this work that we're doing with companies like CoreOS, where we're taking this new approach to applications with containers and the orchestration of those things, getting it up and running on Azure to solve these kind of problems. Can you tell us a little bit about the work that we've been doing together and how that's gone?
Yeah, so we have a mutual customer that was running on another platform and wanted to also use our product Tectonic on top of Azure. And so we engaged a bunch of the Azure engineers. We invited them down to our office in San Francisco, and then also did a hack session up here. And we really quickly were able to get Tectonic up and running on Azure, taking advantage of some of the newer features that you guys have unlocked with storage.
And now, how do you think about taking existing technologies like the Fortran and then putting it together in these environments?
Some things you can kind of lift and shift it into a container, and that works well. Other things you actually can lean on using virtualization again to run VMs inside of a container. We've used this at one of our customers to containerize a very, very old system that is still in production today. So ease that operational burden of maintaining this super old piece of hardware, bring it in virtually into a containerized environment.
It's interesting because that's one of those areas we deal a lot with enterprise customers where, you know, the movement to the cloud isn't this, you know, magical off we go. You know, having containers and other tool sets to work with apply sort of these modern techniques to, it's sort of a step forward, I think, for everyone.
You talked about this notion of storage and the Azure Key Vault being integrated. We've got a clip of some of that code in operation. Let's take a look at that.
Great.
Hi, Rita.
Hey, John. I'm going to show you what it's like for an enterprise developer to push an existing application to the cloud, leveraging solutions like containers and container orchestrator solutions like Kubernetes on Azure.
Great.
We're just running a simple application that has 3 tiers, the database, the API, and then the web tier. This is running on a single VM on Azure. I have a script that deploys everything. It is pulling the Mongo database image from Azure Container Registry. And
that's your private enterprise repository.
Exactly. And it is also mounting the local file system to the container so that we can persist the data.
Okay.
So next we have the API layer. And this is a Java Spring application that allows us to serve the data. And then we've opened up the port on 8080 so that other parts of the application can talk to it. And it is also talking to the database with this connection string. And next we have the web component, which is just running the Tomcat piece, and it is also talking to the API layer, and this is the endpoint for the API layer.
Great.
This is basically the container that's running on this dev machine. So this is all working great for development, but now I want to push to staging and production, and this is where a container orchestrator solution like Kubernetes can really help. In my organization, the IT group already provisioned a Kubernetes cluster for me on Azure, so I'm able to just worry about pushing my applications. And here, what I have doing right now is listing all the VMs in the cluster. And here we have a Kubernetes master and 5 agent nodes that is waiting to serve applications like this one.
In this case, we're running on Azure. What's going to be involved in taking one of the components and actually getting it up to that Kubernetes cluster?
What we want to do is do the same thing, but describe it so that Kubernetes can deploy all these containers for us and understand what resources we need, what images to pull, right?
Okay.
I've gone to GitHub and going to the Kubernetes repo, and here I've just gone ahead and grabbed a sample YAML file that describes what I need for
All
each
that
one of these
configuration.
components.
Yep.
Correct. I've updated that YAML file so that I can tell Kubernetes, here's the database piece of my application.
Yep.
And I'm able to describe to Kubernetes, deploy to this namespace, Contosol, and pull the Mongo database image from my private Azure Container Registry. And I've also described to open up the port here so that other components of my application can actually talk to the database.
And you made a similar set of edits to create YAML files for each of the web components that describe how they work.
Yes.
So let's deploy this one as well as those other two.
We're going to deploy the database one. Now we're going to do the API one and the web one.
Okay. And so once this is done, we should have our app up and running.
Yeah, definitely. It's already provisioned these containers for me, and it's running in the cluster. But in order for me to actually reach these containers, what Kubernetes allows me to do is create services like this, and that leverages Azure load balancer that allows us to
point to the
exactly to route the traffic to the right containers.
Okay. It'll give us a public IP address.
Exactly. This is my web component, and it is hosted on this external IP.
Now, I noticed you had used Mongo inside of a container. And that's a great kind of thing to do during development. But in reality, if we were running this thing as a real application, that data wouldn't be persistent.
Yep.
What do you do?
Yeah, I'm glad you caught that. This is where we had our YAML file, and there was no persistent storage. What we want, however, is an external storage that allows us to persist the data even if the entire cluster is gone, right?
Yep.
So there are many ways to do this in Kubernetes, but coming soon in version 1.7, we are now adding Azure Managed Disk support.
And what's that give us?
Well, with Azure Managed Disk, you can have highly scalable and highly available SSD premium storage.
Wow. Okay.
This is the new database YAML description file. So here is a volume mounted here. So the Mongo database is actually going to read and write to this file path. And to the container, it's actually going to create the managed SSD storage from the storage class.
Can you go back to your original script? And I notice in this, you've got a path to the MongoDB, and I see you've got a complex password in there.
Yeah.
That's pretty common during development. You just kind of hard code the passwords in there. That's not going to work out in a real world deployment.
So what we can do is we can actually, again, similar to the database one, but we can update it so that we can leverage Azure Key Vault. Now, with Azure Key Vault, we have a secure and compliant way to store and retrieve all of our certificates, our secrets, our keys, and so on.
Yeah.
Instead of referencing the connection string from the Mongo database, what we're doing instead is we're telling it to attach a volume and getting the key from Azure Key Vault.
Oh, that's pretty awesome. So if we bounce back to the test app, we should be able to see everything running. Now, it shouldn't look any different, but this is now a very different app than that initial app we started with.
Correct.
That's pretty amazing that you were able to do that so quickly.
Yes, definitely.
So thanks, Rita. Really appreciate your coming here and giving us all of the insights and showing us how to go do this. Can you tell us a little bit about how the actual hacking on this went?
The customer had a set of applications that they were bringing over to the cloud, and so we ended up walking through a bunch of architectures of how should we get traffic into these clusters, either using native Kubernetes ingestion or kind of wiring things in directly with port mappings and that type of thing. Talked through different scalability concerns of each architecture, and kind of went from there, and the customer is off and running right now.
I want to go to this Hackfest because I want to know if they let them play with the railgun, if they let them help pull the vacuum on the, there's Hackfest for software, and then there's a Hackfest on your entire system. When you think about the actual, coding over those couple of days, what problem did you guys narrow in on and spend time on, and sort of where were things helpful and where did we run into some blocks?
So we were working on one of the earlier Kubernetes deploys on Azure to get some of this new framework deployed. Some of the stuff was, of course, a little bit green. It was one of the first deploys. There's some sticking points there, but luckily we have these partner Catalyst guys to help us out and get this stuff deployed smoothly.
One of the things that was really cool is when we were hitting some sticking points, getting Kubernetes going. One of the Microsoft guys said, "You know what? I'm just going to contact the guy who built Kubernetes," and within 25 minutes we talked to him directly and had that answer solved. And we're like, "All right, well that was easy."
We've made some progress. We've got some things going. How do you? And I'm going to ask both sides. How do you think about the future? Like, what's interesting in the next year, in the next 2 years? I mean,
what happens with containers? What happens with modern apps?
Well, specifically with the data science project at General Fusion, once we're managing this data and able to kind of share and expose our considerable amount of experimental physics data, one of the things, in addition to sharing it with external scientists, we're also interested in once we're able to manage this data and do more things with it, to then apply modern data science tools like machine learning. So that's the second Microsoft Hackfest we're looking forward to doing.
And we're looking forward to accelerating folks like yourselves to, focus on your day-to-day jobs and not be running all of this infrastructure that as you have a huge amount of data, it's getting more and more complicated. We think that we can streamline those operations for you with self-driving infrastructure, automatic operating system updates, as well as cluster updates, such that you're building your containers, you're worrying about your code, you're generating money for your company, or you're furthering humanity in your case. But we want to help you do that on the infrastructure side.
I like the furthering humanity. That's a good line.
Yeah.
What's amazing is just how often containers is the right solution for the right job. Like, we've got our build environment, our deploy environment, everything's a container because you no longer have to worry about it built on my machine, it didn't build on this machine, which version of this you have installed. Isolation. You know exactly what you've got and what you're getting.
This is a really good point that we find containers, when they have to be stored in a centralized location, provide a really nice touch point for security. You can start scanning these images, seeing exactly what's in them, and if you need to do auditing on your side for is version A in this container or not, you can find that out, but also is CVE XYZ also in that container, and easily solve that problem. This is targeted at smaller companies as well as huge enterprises that need to have auditability of these things.
You could probably do that in a container too.
Oh yes, it runs in a container on the cluster as well.
Yeah. Well, look, we appreciate you making the time today and the partnership and just the ongoing dialogue and the conversation. So keep it up, and we'll look forward to continuing to work with you.
We appreciate all the help and working together on doing big things.
Yeah.
Yeah, let's onboard some more customers onto Azure.
Awesome. Love it. Thanks.
Thanks.
Now we want to get into the UI aspect, and one of the great conversations going on right now is new UI paradigms, really, or interaction models. And in this case, sort of virtual reality, mixed reality, augmented reality. That's the conversation we want to have. And so first off, let's do some introductions and a little background.
So I'm Sylvain Duro. I'm the founder of Visua with my partner, Ed.
I'm Ed Ventura. I'm the president and co-founder of Visua.
My name is Jeff Sorensen. I'm the president and CEO of Terra Recon. We're working with Visua with very detailed image renderings that we can put within the HoloLens. And there's much, much more to come in terms of what we can do with measurements and with pre-surgical planning and even the application of artificial intelligence in medicine.
And as a matter of fact, we had an opportunity to take a look at Visua. Why don't we take a look? What we're going to show you today is Visua's technology, and what we do is we do high-speed computing on Azure GPU. We're going to stream data to your HoloLens, and you're going to be able to manipulate in real time without any computing power on the HoloLens itself.
Awesome. Looking forward to that.
Let's take a look. The heart that Sylvain is bringing up now is very important as a practical use today. Surgical planning is an option. Also, doctor-patient communication is important. Patients don't understand what they're actually seeing from a general scan. So in this particular case, we've taken a CT scan, put it all together, slices of bread forming a loaf of bread, and what we can do is show the individual, the patient, the colleague, anywhere around the world, and talk about the same object in real time.
No, it's cool. We can collaborate. You know, if either one of us was a doctor, you know, you can see this whole thing here, which is really cool.
Yeah, if Sylvain just kind of steps in, he can actually move into the heart itself. What's important is not just seeing the surface of the heart, and I think that looks great. It's really more important to see the detail of the heart on the inside. We don't lose any information that comes from the scan itself. That's really the important. Basically, what you see is what you get. Anything off the scans is going to be captured in this particular stream.
Yeah, it's pretty incredible because the whole notion of sort of the holographic 3D image to start with is impressive, but then the ability for both of us to see it at the same time and collaborate, it's super unique, and you can't think of a better case study than medicine.
Well, and HoloLens as a client and Azure GPU are really going to be key for us.
Thanks so much. Appreciate you making the time.
Thank you very much.
Yeah, thanks a lot.
I love that. Thanks for spending the time with us on that. And speaking of cool technologies and demos, let's continue around the table.
Yeah, I mean, my name is Amish Sabharwal. I'm the Executive Vice President for the Americas for Aviva. Aviva is an engineering information management software company that back in the 70s had first brought 3D visualization to the complex processing industries like oil and gas, power, and petrochemicals. Since then, we've been bringing this technology to the masses, and this year we're bringing in mixed reality with HoloLens, and take a look at our demo right now.
So last year on stage at Build, we showed on a Surface Hub an Aviva mock-up of an oil platform.
We did, yes.
Super cool. Sounds like there's some progress, some new things. I got a HoloLens in my hand, so what do you got to show me?
So today we're going to look at a technology demonstrator. We've taken that oil platform, a smaller version of that, and put it into the HoloLens to show our customers what an immersive experience would look like. So let's put on our lens and take a walk through the demo.
And I see an Aviva board, basically like a drawing board here with
yes, you can see it's a full-size A1 drawing, and you can get up very close to it and see the intricate details.
I can see everything. Very cool.
Good way to see full-size drawing 2D information in the HoloLens experience. So the drawings are an older, antiquated technique for collaboration between engineers and designers. So with the introduction of 3D, we'll click on our 3D button.
I just did. It's sort of flowing down. And there it goes. It's coming out of the picture.
Great.
That is slick.
So now we have CAD data. So the next step in our demo is to take this model and put it on the floor and enlarge it.
Yeah, I see enlarge 3D, so I'm gonna go over here, enlarge 3D, and it says to look over here, and it's now, oh, there it is, look at that.
So now we should see the model in front of you.
Yeah, I see it.
Coming up from the floor, and it plays a little construction sequence.
Yeah, it actually grows and it colors in, so I can see the tall piece here, and oh yeah, this is slick.
So we have audio in the demo as well, so you can hear just some ambient construction sounds.
It says follow your gaze. This is,
So this is a 1/8 scale model.
Yeah.
It's about 10 feet tall, but still lets you fully immerse yourself in the 3D model, walk through it, and get up close and personal with the intricate details.
And it says this guy's little menu here.
Yeah, so we have this digital concept of digital asset. So, for example, show feed pumps.
All right, so show feed pumps. There it goes. And so all the colors have gone off everything but the feed pumps now.
So this will show the highlight certain parts of the model.
Yeah, the pump's over here. There we go. Okay, yep. There they are, right there. And you can see all the piping they're connected to, and they come around the other side. Slick. All right.
So next step in the model is over by the easel, you'll see
I see a human.
Yes.
Our factory worker. Locate our friendly plant worker next to the drawing board. Air tap him, okay?
So we're going to air tap and place him in the model.
Okay.
So in our industry, we do ergonomic checks when we design 3D plant systems. So we put a scale man in the model.
There he is.
See if he can reach valves.
Right.
So next we're going to take the model full scale.
Okay.
So we're at 1/8 scale now. So
let me back up out here so I give it some room. I see on the right here it says full scale.
Yes.
So let me go. There we go. So now I'm on the floor of the plant. There's my worker. My worker's over there. We're about the same height. Yeah, that is cool. So this thing is now all over the room. There's the feed pumps. I can see those over there now.
So the model's bigger than the room. So navigating through the model, we've had to introduce a teleporting capability, so you can kind of jump and teleport.
Yeah, it says teleport. So say enable teleport. So I'm going to enable teleport.
And then use your gaze to.
Okay, I see it. Yep.
Focus on a spot.
I want to go up on the top of these ladder up here. Oh, slick. So now I'm on top here, and now I can look down. Oh yeah. Wow, it's.
So this experience.
That goes all the way through the roof. I want to go all the way up there. Now I'm basically on top of the world. Holy crud! I can see the man down there.
Yes.
That is really cool.
So the last piece is we've got 3D sounds. We have spatial sounds in our experience.
Okay.
So we've this is kind of a live digital asset. So
it says follow the sound to the faulty pump.
Yeah. So let's teleport back down to the ground floor.
Okay. I'm going to go right next to the man. There we are, brothers in arms.
And the challenge is to find the pump that's sounding like it's about to fail. So there's a 3D spatial sound we put into the system.
Yeah.
So as you walk through the 3D environment, the sound fall off increases or decreases.
Yeah.
And there's a pump that's starting to fail.
Yeah.
Once you find that, you click on it. It should be on the very corner or the very edge of the 3D model.
Yeah. All right, we'll shut the pump down. So as a worker now, I've figured that out.
Yeah, so we can get 2D information into this HoloLens mixed reality world, show maintenance procedures, troubleshooting procedures right there in the environment itself.
Slick. I mean, last year I thought it was pretty cool to blow it up on the surface of. It's a whole nother world to be able to step into the model.
It is.
Teleport around, put a human in it, put yourself in it. I'll tell you what, I can't imagine there's anybody you work with who doesn't try this out and go, holy crud.
Yeah, all the customers that we show this to are super excited about it and are coming up with ways to use it with their own
awesome
companies.
Awesome. Well, thanks so much. I'm going to pull this off now and get out of the plant. That was incredible.
Thank you, Steve.
Yeah,
Appreciate
thank you so much. Thanks for making the time, and thanks for the incredible progress.
You're welcome. Appreciate it.
You can just sort of see the movement forward in terms of the technology and the capability and bringing it to life in true mixed reality fashion.
These are pretty sophisticated, complex models that we're looking at, whether it be in oil and gas, medical, streaming them from the cloud. I think one of the things that's been great about the Babylon project is just making 3D so accessible. In fact, we did a little bit of work on that. Why don't we take a look at that? What is Babylon.js? What do people use it for?
So Babylon.js is a free and open source 3D engine running on every WebGL platforms, and it's to build games or 3D experiment in the browser.
Nice. You're on version 3. What's in version 3?
A lot of stuff, but mainly a new playground. We're currently improving a lot of performance, and we're working on VR.
So let's take a look at a couple of those things. So I've been playing with a playground. The whole thing's written in TypeScript.
Yes.
So you get statement completion, and you can see all the information about the calls. I mean, check this out, right? Sphere dot position. I get all of that stuff, and I could say plus equals 1. And if I just hit run, I can move this stuff around. It's so cool to just be able to use this free-form JavaScript editor with all the statement completion because of that TypeScript work.
Yeah, the idea is to let people playing with the API rather than directly learning by reading the doc, which is really cool.
Yeah, now, if I do window.add event listener, and we just do a quick event listener for, say, the key down event, and what I'm going to do is I'm going to put a quick Lambda function in here, which we can do now, right? This is a cool thing about the browsers. Let's just now do that same move. We'll do the sphere.position.x plus equals.
Should be perfect.
Like that will have me actually doing a kind of interactive system here. So the next big thing that you said was this VR stuff.
Yes, and also the beauty of, JavaScript and what is working cross-platform and browser. So maybe let's check the other part in a special build of Chromium.
So here's a scene. This is just like kind of what we built before, maybe a little bit cooler.
Yeah.
What would it take to add VR to this?
Well, you see, currently we're using a specific camera, which is a universal one to be able to move using the keyboard, gamepad, whatever. We just need to switch this line, and maybe we should have a look to the documentation to check if we have
here's
good enough
here's
documentation.
The Babylon documentation. You have these overviews, and what we want using the VR camera?
Exactly, let's check.
Okay.
The simplicity of Babylon is to switch the behavior with just one line of code. So let's copy-paste this line of code.
And really, this is all I'm going to need to change to get VR going here?
Well, let's check that together.
Okay, so here, I'll just comment this line out so we can kind of compare. And look at that. So instead of the universal camera, we're doing the web VR camera.
Yeah. You could have used IntelliSense and
just done
switched.
it. Okay, so if I run this, what do we get?
You see, we've got a double rendering because it's VR. And now maybe you want to test that inside the headset. This is the Oculus Rift.
Oh, this is the Rift,
And
okay.
the HTC Vive is also supported by Babylon. Yes, we are currently supporting any kind of devices.
Okay. Wow. Oh, so very nice. Holy cow, you can see the whole scene. Very nice. It's super smooth.
It's very smooth because in VR, we're rendering faster than 60.
Now, I see down here some controllers sitting on the table. What would it take to add interaction?
So by default, in Babylon, you have the controller being displayed, but we don't have a default behavior yet.
Okay, so you can see the controllers, but if you want to do something,
you need to write some code. You can see that we are sending a ray, and this ray
That's this Babylon Ray helper you're sending.
Yes, this is a single line of code, and when you're moving the controller, you can see that it's moving the ray.
That's super cool.
You can select an object like that, like the cube, it's showing the colors. And you can see it's currently drawing something on the floor. The idea is when you put the headset, be able to select something and then to jump directly there.
Ah, so we just did kind of a teleportation. This is move, teleport, selector 2.
Exactly.
So if it's the ground, we jump to it. Otherwise, we can go select objects.
Then
Gives
you
you a
need
cool
to
way.
choose which object you want to interact with and which kind of behavior you like to code. And this is the role of the developer to do whatever you want.
Cool. So the thing that's amazing about this is just how easy it is to put together very sophisticated kind of interactions and all open source.
Yes, it's all open source, so if people want to contribute and say that our current VR implementation is maybe not good enough, we're really listening to the community to adapt the code itself, and people, most of the time, this is the beauty of open source, contribute to the code.
Awesome.
Thank you.
Many of the problems that we're off tackling now are these very deep industrial kinds of problems where we're looking at a digital replica of things that are in the physical world. Our teams have been working together to solve these kinds of problems.
Well, I got a couple experience. I was talking to our CTO and our development group, and they wanted to give a shout out to the developer experience organization, especially around HoloLens. They've been working tirelessly, integrating, having phone conversations in the middle of the night, because we're in Cambridge in the UK. Having hackathons, I guess, is what, I don't know what that actually means, but we appreciate and thank you for all your support. But we got a lot of work to do still.
Two questions in one, which is look forward a little bit. What do you see in the next, year, 2, 3 as you're working on this? And then what are some of the challenges we collectively still have to overcome?
Well, I think kind of going back to how we're really working together, any kind of information that's coming out, anything that's coming out of Microsoft that kind of helps us build for the next version, of any kind of technology that you have is really important.
We've been utilizing our relationship with Microsoft to really push the boundaries on GPU computing. We're in 85 or so of the top 100 hospitals, so our customers are generally large customers, and most of them are, of course, utilizing Microsoft products. Inside of our system, we had an ASIC-based board, a custom board that we built, and we just moved off of that board to do huge amounts of rendering. It was just simply never possible before GPU-based computing came not even of age, but really just recently was capable. And now Microsoft, they understand HIPAA security, and at the same time, they were a first mover into GPU computing.
I think maybe a metaphor, when I was my kids use Minecraft, right? And they're building things together as teams. So in the industrial world, it's the same complexity. We have engineers that are spread out all over the world that are designing complex assets. We've kind of been able to solve that with sharing data, but we haven't been able to solve that in the Minecraft sense, where we're looking at the same 3D object and working on it collaboratively together. So I think that's something that I'm looking forward to for you guys to help us with.
So we have that today. So it was one of the first things that we need, because a surgeon, he can't have an HoloLens
alone. So many surgeons has to have the same environments. So today we are building the same scene at the same time. And the beauty of the GPU Azure, you can bring all the file in the VRAM and you can share all the view for everyone.
Sharing content, I agree, but now like multidiscipline teams like process mechanical, instrumentation, electrical, different engineering disciplines where they're on the same object, but they're doing their own thing.
Yeah,
right. Rather than I don't have to. I just have to see what that other guy's doing, but I'm doing my own work.
This is sort of a really phenomenal kind of conversation. If you think about what's going on in terms of CPU and GPU, just the compute power in the cloud, that next level of that AI capability, and then if we take HoloLens, sort of on the front end, this mixed reality, that ability to bring it to life in 3D models, the ability to collaborate together, it's sort of things that people haven't thought about. It's that next generation in many ways where, we think about gaming and the fun aspect of this. The truth is these complex business processes and models and collaborating there could be the difference between life and death. Could be sort of a change in the way energy is driven or created. I mean, there's just such possibilities. So we want to thank you for your time and for your partnership, and we appreciate you making it today.
Thank you very much. Yeah, thank you.
I think I'm seeing a drawing. What is it?
It's a picture of Isaac Newton.
According to Wikipedia.org, Isaac Newton was an English mathematician, astronomer, and physicist who is widely recognized as one of the most influential scientists of all time and a key figure in the scientific revolution.
When was he born?
Isaac Newton was born on December 25th, 1642.
Wow!
You look surprised. Did I get it right?
Yes, you did, Zembo.
Can you draw another picture?
Yes, I'll draw another picture of Neil Armstrong.
All right, well, we've been having a lot of great conversations today, and I think John and I are both pretty excited about this one. This conversation is about bots, and this one's really fun because we have sort of in many ways, the creator of our bot framework from Microsoft, as well as one of our top customers in terms of using it with Sage. And so I'd love for you to each introduce yourself and tell us a little bit about what you've been working on.
I'm Lily Chang, and I'm a distinguished engineer in Microsoft in the AI division, and I run the team that builds the bot framework as well as the language understanding tools. We have about 130,000 developers building the bot framework, which is pretty cool. Just really psyched for this conversation, because for me, where it all becomes magical is hearing what people are actually doing with it.
Awesome. Hi, I'm Kriti. I work for Sage. I am the VP of Bots and AI at Sage, which is a dedicated role we've created because we absolutely believe in the power of bots and AI. Just to give you a bit of background, Sage is a global enterprise company, accounting, payments, payroll, applications, and HR for users in 23 countries around the world. Our relationship with Microsoft has been absolutely awesome. We've been building bots on the bot framework for a very long time, almost a year.
Which is a long time in bot space.
So can you tell us a little bit about how you think about the pieces of the bot framework?
So it's interesting because we actually started by building our own bot a long time ago, and we thought, wow, we need a developer in our team for each channel that we want to have our bot surface on.
A channel?
So a channel is really just an app where you can converse. So something like Skype or Slack or Facebook or Kik or just the web. We found that people want to be able to have a conversational interface wherever people converse. And so we just wanted to make it really easy to publish your service or your bot in lots of different canvases.
So Kriti, you're actually using both pieces, right?
That's right. We love the multi-channel approach because, as I said earlier, we operate in 23 different countries, and there are different channels that work in each one of those. And Facebook Messenger might be a great platform for an entrepreneur running their business on their own, but there could be a larger enterprise who are using Skype or Slack. It's important to customize the experience for a channel-specific users. And also, if you look at the use cases of workflows we are going after automating, we want people's work life, running their business to be as easy as talking to a friend.
You mentioned this notion of people think of the bot as their friend. As you were building the bot framework, Were you thinking about these kind of commercial applications?
You know, we started building social software a long time ago, and so we really know that no matter where you work, a lot of what you do is just conversation, right? And so how can you make these everyday tasks easier to use? I mean, it was really our hope that people would try to do more complex things. But I've always been really interested in the process of, you know, a company sees the data and then they learn, oh, my customer has this question. Can you talk a little bit about, you know, the data that you get back from the bot and how that knowledge kind of feeds back into the whole system?
For us, this was a new journey because it changed how we manage or create product roadmaps. So previously, well, and I say in the old times, I mean like a year ago. So a year ago, if you had to decide the next 3 features to build for any product, including a bot, you would do a user research session, right? You'll bring people in and you'll show them the product, or you would do a survey afterwards. And now users just tell us what they want in a natural conversation, just like you're talking to a friend. Hey, you did this task for me, great. Can you also help me with something else? And that is product development for us. That's our roadmap sorted. And we can quantify it, and that's how we make decisions. We have become much more data-driven.
We've been talking a lot about the bot framework and channels and how all this fits together. We have a video of using the bot framework for a pretty novel application, which is connecting that same conversational interface to a robot. Should we take a look? Hey, Matt, welcome.
Thank you.
We've got this really cool robot that we've been working on with our partner, ASUS.
Yes.
So built into the robot is this ability to listen, send that information up to the cloud, and use the Microsoft Cognitive Services to recognize the speech. And what we're going to go do is add some special new functionality using this cool thing called the bot framework that Microsoft has been producing. So I've got Visual Studio Code open, and we're going to load in the bot builder and use the Restify library to create the listeners that are going to be required to send messages back and forth. We go create the REST server, and we're going to pull out the information like the port and the app ID and password from a .env file, and it'll all be up and running. So let's get down to the meat of this thing, and it's really simple. One server.post, set it up to listen to post messages, set it up to that connector to listen, and here's our code for a bot.
Yes.
I mean, it's really pretty amazing that we can create a fully interactive bot with just this little bit of line of code. So we'll just echo back what we heard, and we'll send it back.
All right, so you're just repeating back whatever we tell the robot.
Yeah, now you can do some other really cool stuff with the robot.
Yes. So because the robot has a face, right? So the robot can smile, can shake the head, and so on. We added a little bit more capabilities when we respond. So if I scroll down into this little piece of code, that's how I say, this is the facial expression I want you to show when I'm saying this thing.
Got it.
Right? So we're assembling this into a message, and I have this method called buildAnswer to do that. So what we can do here is coming back to what you just did, which is the response I've heard. And what we can do is buildAnswer, builder, session, and response. So what we're doing now is taking your I've heard something and adding all these emotions, moving heads, and saying, go robot, do that.
That's pretty cool.
So we git deploy this. So git add, git commit, and test, and git push.
All right, so now that's off. Because we've changed GitHub, the server's going to go auto-update.
Yeah.
Should we see it in action?
Yeah. Hey, Zambo, say something.
You said, say something.
Very cool. Now, Matt, it would be fantastic if we could have the robot kind of understand what it was seeing and contextualize that as part of the response.
So we have this new API called Custom Vision API. And what's interesting about it is that I can teach it to find out in images what I want it to find. So for example, we're interacting with Zambo, and maybe I want Zambo to know if it's an empty room, or if I'm in front of Zambo, or if I'm showing something to Zambo, a picture or something. Then I basically just upload my images, right? Images of me holding pictures and say, these are pictures. And what I do is I just tag them. I say, this is a drawing, this is a person, this is a room. And when the model is finished training, what I get here is a URL I can call. It's basically a REST API.
Yeah, okay.
Right? And I ask, what are you saying now? And I get this response. So what we are going to do with your code is add these into it. So Zambo uploads images to our blob storage. So next time when we're talking to Zambo and receive a message, we're going to check this blob storage and ask the Vision API, what is this? And so now
it'll give us back that tag.
Right. So let's do that. So what we're going to do is I wrote this little REST call here. That's just a REST call. It's a request calling node.
Okay.
And all I'm doing here is giving a URL, which is our custom Vision URL. And I'm asking, what's this image? Call it, check the result, and respond with the JSON that I get back.
Got it. Okay.
So what we do back in your code here is we call this method called analyze custom vision. And this is how Zambo tells me this is what I'm seeing right now. When I receive a message, and the message contains text, it also contains other things. And in this case, Zambo gives me, this is the URL for the image I just saw when you're talking to me.
Ah, very cool.
Right? So what I do is add this image here. And of course, this is an asynchronous method. So what we do is we have a result.
Lambda function here with the
Right.
callback. Yep.
Yeah.
Move that code down inside.
Right. And I see, right? And in this result, I have predicted tags. Zambo may see many different things in the same image. Maybe I'm seeing you, but I'm also seeing a cat, and I'm seeing a door, right? So it's going to give me an array of these things.
Yep. Okay.
In this case, I'm just guessing. All I care is about the first item in that array. I don't care about anything else.
Great.
And this is it. So now I'm saying I'm seeing a drawing, I'm seeing people or an empty room. So let's do the git thing again. Git add, git commit, second test. You can pretty much say whatever you want.
Got it. Okay.
Yeah.
So, hey Zambo, what do you see?
I see. Drawing.
Awesome.
That's pretty cool. It works.
Yeah. Now you've got AI being used to do the speech to text. You've got AI and that training that you did around the images, but all that stuff is packaged up into these super easy to use modules so that we can add intelligence to a robot.
Or anything.
Yeah. Well, really appreciate your showing us that.
Thanks.
Have a good day.
You too.
And I think one of the things that's fun is this notion of a physical instantiation of both the cognitive services and the bot framework, where you sort of get this manifestation of what it can be. And there's a ton of fun both to build that capability, working with ASUS, and then, of course, what it comes out with.
We were sort of laughing when you said, a long time ago, a year ago, not very many people were looking at bots or even using the word AI. And now speech and dialogue and, these physical instantiations, that just seems like it's taken off in the last 4 months.
Since we're working on faster time frames, what do you see in the next 6 months to a year that's of interest to you in this particular space?
I think this next year we're going to see people really start to understand what are the building blocks in bots and have more predictable ways that they can interact and just better examples. Because we know this ecosystem is early and we really want to think of ways that we can help developers, help investors, help all the channels build their business on these tools.
I think consumers will become more aware of what a bot is and stop asking it out on dates every time they talk to them.
Awesome.
And that's progress.
Yeah. Look, we appreciate you guys making the time today. This was a great
you.
conversation. And so really, really, thanks for making the trip. Thank you for coming over, Lily.
Sure.
Thanks a lot.
Thanks, guys.
Hey.
Good to see you, man.
Yeah,
Good to see you.
look at that. Hey, brother.
Good to see you.
Guys, look at this.
Hey.
Come on in, guys. Make yourselves at home. This is pretty cool. So we've been having conversations all day with developers really around different parts of the technology stack. And so we've been talking containers, mixed reality, bots, all types of things. But one of the things is that everybody at this table has been with us for a while. We've had the opportunity to work with Gobbler and Music and Picket and Sensoria, going back to build 3, 4, 5 years ago. And so I'd love to hear a little bit about the technology journey for each one of you.
Working with Microsoft has been eye-opening because what started out as one platform, one SDK, a simple kind of vision. Where we are now is we have an SDK that can grow with the customer, grow with the companies and partners we're partners with. And so now it can enhance all these different experiences that people want.
For us, it was actually a blend of things because not only are we a cloud-based company, but we also have a desktop application. And our application is actually sort of an application of applications because we're actually using it to download and install other applications and authorize them. The transition from Amazon to Azure for us was actually so painless. It actually happened in a matter of about 6 minutes. We could never have done that on our own. You know, you're the biggest software company in the world, and you have the resources to transform yourself quickly over time. And so what happens with us actually is we find that we're behind your changes. I'll read something and go, wait, when did they put that? When did that happen?
Partnering with Microsoft, that was so scary in the beginning. Of course, there are things that we are missing in the beginning when it comes to some of the APIs weren't ready for us, of course. But I mean, we had the opportunity to work together with the guys to say that, okay, we need this part of the API open, we need this open, et cetera, et cetera. Was it painless to go from AWS to Azure? For us, I think it wasn't really that painless. It wasn't 6 minutes, actually. It wasn't super hard, but it required some work from our side, of course, but also from the Microsoft side. We made a lot of good partners to partner with inside the Microsoft ecosystem as well.
And the other great thing is having the ability to choose almost a la carte components that are more or less powerful depending on what you need to do. Things like that really makes the work very easy for the team.
So it'd be interesting to hear your perspectives on what kind of went well when we got our developers together, and then what were some of the challenges and how we overcame them.
From the very beginning, you started to listen to the ideas that we had. That is how a true partnership actually looks like. That it's not just us screaming for more resources or more technology or better information or whatever it could be. We also have to give back. And I think that you have really had people encouraged to do this. And that is what I think is the most fantastic thing.
For us, it just wasn't clear how to unearth everything, and if we're going to move to it, which at the time was a more modern platform in a lot of ways, there were things that didn't exist in Azure when we first got started. And so the devs started with, well, are there workarounds? And then it was, oh, actually, maybe this would be something that we should add in. And that's when everything clicked for me. It's rare when you actually get to work with supremely experienced devs, and I think that actually really helped at our company change a certain amount of our thought process. I don't think my team would have moved as fast as they did because they didn't feel like this big company was overpowering them and telling them what they were doing wrong, but it was almost like guidance and a little like Yoda namaste that came in, that they needed, because they were just getting stuck in things that maybe a more experienced developer wouldn't get stuck in.
I constantly tried to criticize myself and my team to try to, in the hopes of trying to become better. I guess answering your first question, what were some things that maybe didn't go well? Yes. The bad is, I think transparency, maybe seeing a little further out in the future, because as we're, allocating resources, time, budget, people, not knowing certain things exist until we're already kind of 2 feet into something, it means that I get a little frustrated because I wish that I could either hurry up and finish this, or I could then get another team working on this other thing. So having transparency might allow us to make better informed decisions.
Good, solid piece of feedback, and totally fair. I mean, your collective contribution to the code. John and his team write a summary up about once every 4 months of all the feedback we get, both from the startup community and other developers, and we bucket it out. So it could be Bluetooth issues in Windows, it could be something on Azure, it could be the APIs for O365, and these are all areas, that we've worked on, Azure on the same thing, and over time your feedback has actually gone into the product groups, and one of the things we're able to do is aggregate that feedback up.
Yeah, across all the different companies, so we can really see some trends.
With real examples, with real code samples. So when you share your code and we work with you on that stuff, we can use that to go back to the product teams and say, hey, here's what needs to change, and here's why, and here's the scenario they're trying to enable. And changing topics a little bit, what advice would you give for startups that are paying attention here and watching?
Can I start?
Yeah, absolutely.
For all of us, I think we're doing this based on passion, right? So it's super important that we actually keep looking into ourselves and say, okay, why am I doing this? I mean, of course, you should listen to the input you get. Create this foundation of trust and passion. That is how you actually create something that's really good, I think.
I actually echo a lot of what you were saying. If you're not committed to it, then no one else will be either. And I always tell my people, no one works for me, they work with me. And I think that when you have that mentality, I think that you can really get the most out of people. And if you get the most out of people, then you actually have an opportunity to change the world. But if you don't believe, if you won't do everything to do that, then don't expect that to be handed to you.
Yeah. Chris?
I agree with all of that. I would also say people can totally sniff BS, and really smart people can do it really well. And if you're in a high stakes game and you want to have the best people involved in what you're doing, you've got to come forth with who you are and what you believe in and do it in the truest way possible. Because at the end of the day, if you're going to fight the fight and win the war, you've got to do it with everyone fundamentally knowing who you are and what you stand for. And when you do that, you find loyalty, you find good partnerships, and you can find success. And I think on top of all of that, you have to be fearless. You have to be prepared to fail. You have to be prepared for your business to go out of business. You have to be prepared to make the hardest choices you've ever made in your life, even if, it hurts. But it's go big or go home. I mean, this is the hardest fight you'll ever have. And to succeed in it, you have to be prepared to go all out. And if you play it safe, then someone else is going to be right behind you, going for it and skipping right past you, because playing it safe doesn't win at the end of the day. And so if you're true to yourself and you take the risks that are necessary to push your company forward, you'll have a better chance than most.
Awesome.
Yeah, so the path to success is really hard. And nobody will care about the company like a founder will do. So you really have to be super passionate and prepare to fight a very hard fight every day. There are a lot of things that come your way that don't go as planned. You also have to have a plan B and a C, and you will use all of them.
I think learning from your mistakes too, not being, look, cut bait. If you mess something up, I think just moving on and being okay with that, not worrying about ego, because I'll tell you what, we mess things up a lot. But by messing up is how we figure out how to do something better.
I want to end on that one, because I think that advice for startups, we're looking at 4 passionate, founders who they're not in that beginning phase. You've been at it for a while. We've had the opportunity to partner and learn from you guys, all the way to the software code we built, to how our culture changes, et cetera. So I would, say to everybody watching, keep an eye out for Pickett and Sensoria and Gobbler and Music, and, watch these companies and learn from their example. It's just as big an honor for John and I to watch and learn from you guys as it is from anybody else. So we appreciate it. Thanks for making the time. And
thank you for having us.
Yeah.
Thank you so much.
All right, let's close this thing down, Googs.
Let's shut her down. All right, fellas.